We are still on the error component model series. We have covered the estimation of models having constant slope coefficients while the intercept varies over countries. So in this video, I will look at models whereby the slope coefficients are constant, but the intercept now varies over region, vis-a-vis a model having a common intercept. So just like the previous video, two scenarios are considered. A model with a common intercept that is estimated using the pooled wireless estimation, and a model that has constant slope coefficients, but the intercept varies over regions. The estimation technique will be by the least squares dummy variables. So if you have watched the previous video where I estimated the model where the intercept vary over countries, I was able to explain the differences between pooled and panel regression. Equation 1 is an example of a pooled equation, and equation 2 is an example of a one-way error component equation. If you still don't understand what is a one-way error components model, I will refer you to the video titled Understanding Error Component Models. Again, in this video, we are going to perform the poolability test, whereby we want to know whether the pooled OLS model is applicable or the fixed effects model is applicable. If the p-value is lower than 0.05, then we reject the null hypothesis and we estimate the model with the least squares dummy variable, also called the fixed effects model. So we are also going to perform poolability test in this video. So if you are ready, load your data and let us get started. So continue from where we stopped. This is the result of estimations from using 53 country dummies, and this is the outcome of the poolability test. So now let us estimate along regions. That is, the intercept will now change along regions. I have 5 sub-regions, so I'm going to include only 4 dummies. You can see R2, R3, R4, and R5 in this estimation. Same way for the country estimation, you can also use factor variables. So that means you have to create IDs, regional IDs for the sub-regions. If you don't know how to create regional IDs, watch my video on reshape white long. I showed how you can generate IDs in your panel. So I'm going to use this first code because I've generated dummy variables. Let me show you the data again. This is the data I'm using. 54 countries, Algeria, country 1, and Zimbabwe is country 54. Analysis this time around will be along regional basis. There are 5 regions in this sample: North Africa, Central Africa, West Africa, Southern Africa, and East Africa. And because I have these 5 groups, I created 5 dummy variables for them. So here I have R1 to R5. So 5 regional dummies to capture the sub-regions in the data. So back to our estimation. So I highlight this command and execute it. So this is the outcome. You can see here R2, R3, R4, R5. These are the 4 different intercepts for the 4 sub-regions, and the constants here represent the intercept for the base region. The base region in this case is Central Africa, R1. So 15.94874 is the intercept for Central Africa. You can see the results for the regressors. All of them are significant except trade. Trade is not significant, but all the regional intercepts are significant. Let's compare that result to the pooled OLS analysis. I didn't repeat it again because I done it in the first video, so this is the result. So here we can see the pooled OLS where we have common intercepts. The results are significantly different. Number 1, you'll observe that only 1 constant is here. And here we have the results where the intercept varies along regions. So how will you interpret this? For region-specific interpretation, remember I said the coefficient of the constant represents that of the base region, which is Central Africa. And all interpretation must be made in reference to the base region. For instance, GDP is lower in East Africa relative to Central Africa by 0.882. Lower because there's a negative coefficient. And East Africa is R2. That is the dummy variable created for that sub-region. But how do you get the actual calculation? According to Woodridge, this is how you get the actual calculation. You take the exponent of the coefficient, deduct 1 from it, and multiply by 100. So the actual differential between the intercept of East Africa and Central Africa is negative 58.6%. You can also change the base region as desired by your research. If you need to see that code, they are all in the do file. So I can decide to change my base region from Central Africa to Southern Africa. It's possible. So you don't have to maintain the first sub-region as the base. Any of the regions can be used as the base region. So I have all those codes written in the do file just to save time. So next, let us perform the poolability test to see whether these regions are the same or they are different. So I've highlighted that, execute it. So we can see here that clearly the F statistics is below 0.05, which indicates that the regions are different. So they should not be lumped together and assumed to be the same. So the pooled OLS technique is not applicable, but the least squares dummy variable technique. So if I'm supposed to estimate this model, I have to include the regional dummies. Thank you so much. Please support what you have watched with reading. Woodridge is here, Asterio and Hall is here, HCL is here, Baltagi is here. These are very simple, easy to understand papers and textbooks. I also have my papers here where I used least square dummy variables in my analysis. You can read them up. They are available on my website freely, but you have to cut them and check out at zero cost. So now I have covered when intercept varies over countries and when it varies over region. Stay with me. The next video will be a model that shows the varying intercept over time. Please, if you have not subscribed, please do so. Crunch Econometrics is dedicated to teaching beginners and intermediate level users. Please don't go away. I'll be right back.